Hey everyone, today we are continuing our conversation about factorizing quadratic expressions. Last time we talked about the format where it's just x squared plus bx plus c, meaning there was no coefficient in front of the x squared. Today we're talking about more complicated quadratic expressions to factor, and where we actually do have a value that's not 0 or 1 that's in front of the x squared. So it's going to be a little more complicated. Here's an example right here. Factorize 2x squared minus 9x plus 10. Okay, so just like last time, I've laid out 4 different examples of quadratic expressions that follow the format of ax squared plus bx plus c. So remember, the a is signifying that it's a coefficient in front of the x squared that is not 1. So you'll notice that you see that in these problems here. Normally we just had a normal x squared, so then our factor forms, our binomials just had x plus something or x minus something. Now when we factor these quadratic expressions in this format, you notice that one of the binomials, at least one of them, sometimes it's both, will have the first term with a coefficient in the front that's other than 1. It's not just x by itself. So go ahead and pause the video and see if you can find any shortcuts or patterns. Okay, so like we mentioned previously, our first terms are going to be a little bit more complicated. Here we see that our first terms, I have a 2x and an x. Those two will need to multiply to get to 2x squared. Same here, 2x and 2x, those will multiply to get to 4x squared. Here, 3x times x will multiply to get to 3x squared. 2x times 3x will multiply to get to 6x squared. Okay? And then if we look at our second terms in our binomials, do we notice any patterns here? Well, we notice that 1 times 2 will have to get us to 2. 3 times 1 will have to get us to 3. Negative 2 times negative 2 will get us at positive 4. Negative 5 times a positive 2 will get us to a negative 10, because a positive times a negative is a negative. Okay, so far the first term and the last term of your quadratic expression do match up with your binomials, with the first and the last terms. But let's see the middle terms now. The 5x, the 8x, the negative 8x, and the negative 11x. That one is a little harder to see, right? So you'll probably notice that in order to get the 5x, I have, let me go ahead and erase some of this over here so that you can see it a little more clearly. In order to get this positive 5x, I have 1 times x, which will get me to 1x, and 2x times 2x times 2, which will get me to the 4x, so that later on they'll add together to get 5x. Here, 3 times 2x is the 6x. 2x times 1 will get me to 2x, so 6x plus 2x is 8x. Okay? So I do have to do a little bit more mathing to get there. Negative 2 times x is negative 2x. Will be combined with this 3x times negative 2 for negative 6x, so that they add together to get negative 8x. Negative 5 times 3x will get me to negative 15x, so that later is combined with 2x times 2 for the 4x, so that later on when I add, I'll get to the negative 11x. So since we have this value in the front, it's kind of complicating our math a little, right? I do have to do a little bit more work in order to factor. Okay, so I'm actually going to teach you two different methods on how to factor quadratic expressions when it's in the format of ax squared plus bx plus c. All right, so we're going to go over two different methods. Method 1 is called the diamond box method, and method 2 is called the AC method. Both methods will help you factorize problems like this one, 2x squared minus 9x plus t. These are problems that are in the ax squared plus bx plus c format because there is a non-1 coefficient for your first term of x squared. Typically, when we have just x squared plus bx plus c, so a 1 in the front, we would multiply two numbers to get to that c value here. And those two numbers also have to add to get to that b value, right? But now we're adding in a coefficient of a that is not equal to 1, so it's going to complicate things. And we have to take that a value into consideration. So we'll look at the first method, the diamond box method, and see how it differs a little bit. So in the diamond box method, we actually organize our work with this x. It kind of makes the sharp edges of a diamond. I think that's where they came up with that name. And this diamond is cut into 4 different corners that are going to help us organize our work. Okay, so again, we're going to try and find two numbers that satisfy two different conditions. So again, normally we add those two numbers to get to this middle term, this b value. In this case, it's negative 9. For the diamond box method, it's the same thing. We're also trying to get to that middle term. And normally we multiply those two numbers to get to the c value, right? The 10. However, now we have this a value in the front as well. You just write that down so you can see that, what we are talking about when we mean a, b, and c. So we also have to take that into account. We are multiplying a by c to get that product we need to reach. Okay, in this case, a times c is 2 times 10. So we need to get to the product of 20 and also get to the sum of negative 9. So let's go ahead, like before, we will list our factors of 20. That's 1 and 20, 2 and 10, and 4 and 5, and that's it. Okay, so we need to look at these numbers and see, is there a pair that can multiply to get to 20 but add to get to negative 9? Okay, so let me go ahead and draw my boxes like I have before. I need to get two numbers that multiply to get to 20 but also add to get to negative 9. If you haven't noticed by now, I need to get to a positive product, but a negative sum. So that actually tells me that one of them, or actually both of them, need to be negative, because that's the only way that's possible. A negative times a negative can get me to a positive product and also get me to a negative sum. So I'm looking for a pair of factors that will satisfy those parameters. And that leaves me with 4 and 5, because negative 4 plus a negative 5, those are the only two that'll get me to a negative 9, because 4 negatives plus 5 negatives will equal to 9 negatives. And then on the flip side, negative 4 times negative 5, negative times negative will get me to a positive. So I end up with the answers negative 4 and negative 5. Okay?
Okay, so you're probably wondering, all right, so I did all that work. Negative 4 and negative 5 must be my answers, right? x minus 4 times x minus 5. Well, that doesn't work because as soon as you multiply your first two terms, you only get an x squared. And then also when you multiply negative 4 and negative 5, you get a positive 20. That's not what we're looking for here, right? So what we actually are going to do with those numbers is rewrite the original equation. So instead of 2x squared minus 9x plus 10, we are rewriting that middle term into 2x squared minus 4x minus 5x plus 10. Because remember, the whole point of all this is to break down that middle term so that we can then find the original factors, kind of like what we did previously when we were looking for patterns. Okay, so what we're going to do in the diamond box method is we're going to rewrite this, but in a Punnett square. So I'm going to show you what I mean by first setting up a Punnett square. Now, normally in the past, you're trying to figure out what goes inside the Punnett square, but now while you're factoring, you're going in the opposite direction. So you're going to figure out what goes outside of the Punnett square. We have 2x squared plus 10, and then your middle terms go in, I guess, kind of the middle, if you will. So you have negative 4x, negative 5x. And like I said, you're going to try and figure out what terms go on the opposite sides. So we will start here, and we will figure out what the GCF is between 2x squared and negative 4x. What do they have in common? Well, they both can be divisible by 2, and 1x is what they share. So I'm going to place a 2x here. They both share a 2 and an x. Next, we're going to move over to the next column. And what do negative 5x and 10 have in common as their greatest common factor? Well, they both have a 5. And then we might want to add in a negative. I know right now it doesn't make sense because 10 is a positive and this is a negative 5, but remember later on these two binomials, which we're trying to find, are going to have to work together. So we could possibly make it work. All right, now that we figure out the columns, we can go to each row. And you can always start with the rows and then deal with the columns. It really doesn't matter. So what do 2x squared and negative 5x have in common? Well, they both have an x. And let me just double check. Does 2x times x equal to 2x squared? Yes. Does x times negative 5 equal to negative 5x? It does. So then let's see, what does 2x have to multiply by to get to negative 4x? Well, that term 2x can multiply by a negative 2 to get to negative 4x. And then look at this works out. Negative 2 times negative 5 is 10, a positive 10. Okay, so I just put little parentheses here because it's kind of like your two binomials. I can also rewrite this into x minus 2 times 2x minus 5. So then when I am using FOIL to check my work, x times 2x is 2x squared. FO is outer, negative 5x. Inner, that's negative 4x. And last, plus 10. So then we go back to 2x squared minus 9x plus 10. So that's how you use the diamond box method. Again, we did all this work to figure out how we can break down the middle term, negative 9x, into negative 4x and negative 5x. We're using the GCF, greatest common factors, to figure out the binomials that will get us to our factored form.
All right, the AC method. You probably have figured out it actually is a bit similar to the diamond box method because you probably recognize the AC, right? For the first method, we had to figure out the product of A and C because this is ax squared plus bx plus c, right? So we multiplied 2 and 10 to get to 20. So the AC method also is similarly going to use the product of A times C to get to that 20. Okay, so with the AC method, you are taking, well, let's go ahead and rewrite this problem. I'm going to use up the space over here, even though this is not the diamond box method. I'm going to cross that out. We're looking at the AC method. I'm going to recopy this down over here so I have the extra space. We found that the product of A and C was 20. So I am going to do the same thing as I did before with my diamond box method. I'm going to look for two numbers that multiply together to get to 20, but then add to get to negative 9. Okay, so far, same thing. Okay, looking for two numbers that will multiply to get to 20. So we'll list our our factors. We already know it's 4 and 5, right? From doing our previous method. Negative 4 times negative 5 to get to positive 20. Negative 4 plus negative 5 to get to negative 9. Okay, so we have negative 4 and negative 5. Those are the factors we're going to end up with. Now here's where it differs a little. We already talked about how the problem is this middle term, right? This minus 9x, and how we don't really touch the other numbers, the other terms, the 2x squared and the plus 10. Same thing applies over here, okay? I'm going to recopy down the 2x squared and the plus 10. But now instead of the minus 9x, I'm going to replace it with minus 4x minus 5x.
Okay, so just like before, we are going to find the GCFs, but we're not going to put it into a Punnett square. We're just going to keep it like this. So this is where the AC method differs from the diamond box method. We're going to start with the first pair and find their GCF. So what number goes into both 2 and negative 4? Well, that would be a 2. And then what variable do x squared and x both share? It's an x. What's left over will go inside the parentheses. So 2x has to multiply by an x to get back to 2x squared. 2x has to multiply by a negative 2 to get to negative 4x. And then for the second pair, all you're going to do is you're actually going to copy this x minus 2 back here. And then working backwards, figure out what their GCF would be. Negative 5 has to multiply by x to get to negative 5x. And then it works out that negative 5 times negative 2 gets you to a positive 10. So what you want is you want these two binomials to be the same. So once you figure out what your first binomial is, you can copy it back over to the back, and then using that, work backwards to figure out what term is missing over here. So it's a backwards double distribution, if you remember that method from when we were multiplying our two binomials together. Okay, and the whole point of getting these two binomials to be matching is that then they are one of your binomials. And then together, I'll just change to a different color here. This term and this term will be your first binomial. 2x minus 5 times x minus 2, which, if you remember, was the same exact answer we got from the previous method and the correct answer overall.